Alright, and welcome to Quotient of a Logarithm. Now, here in our last video, we said that the log base b of a plus the log base b of d, we could multiply a and d. However, here we're not adding these logarithms, we are subtracting. So I want you to take your best guess. If when we were adding our logarithms, we were multiplying what was in the inside, when we are subtracting, what do you think we are actually going to do with that m and that n? Well, in this case, we are actually going to divide. So when you add logarithms of the same base, you can multiply the inside, and when you subtract logarithms of the same base, you can divide the inside. So we're going to look at four different or distinct examples. Now let's say we have this. Let's say we have the log of base 2 of x squared minus 16 minus the log base 2 of x plus 4 is equal to, let's say 5. Why not? Okay, so what would this look like? Well, we could rewrite it as the log of base 2 of x squared minus 16 over x plus 4 is equal to 5. Now here, you actually have to know some things. You have to know how to factor this, which is actually a difference of squares. We talked about this at great length in the first semester. So we could write this as such. We could write this as the log of base 2 of, and x squared minus 16 can actually be broken into x plus 4. Remember, it's a difference of squares, times x minus 4 all over x plus 4. Okay, so notice I took my x squared minus 16 and I factored it into that difference of squares, x plus 4 and x minus 4. Now notice that there's an x plus 4 on top and an x plus 4 on the bottom. Those two things actually cancel. And so let me pause this and clean this up. And so guys, I've redrawn it right here where the x plus 4 is canceled and we have the x minus 4 left over. And of course this was always set equal to 5 according to the original problem. Okay, now from here we have a fairly simple problem which most of y'all can solve. We see that our base is 2, so I raise everything up into the power of 2, and I now have x minus 4 is equal to 2 to the power of 5. Now, I would actually encourage you to memorize your 2's. They're pretty easy. Look, you have 2, which is 2 to the 1, and then you have 2 times 2, which is 4, and then 2 times 2, which is 8, and then 2 times 2, which is, or then times 2, which is 16, and then times 2, which is 32. And look, 1, 2, 3, 4, 5. So 2 to the 5th power will be 32. So guys, 2's are pretty easy. I would encourage you to memorize those. And then of course guys, to solve this, we'll add 4 to both sides. And we have x is equal to 32 plus 4, or aka 36. Alright, let's go ahead and move on to our second example. Okay, here's our second example. We have the log base 3 of 9x squared minus 25 minus the log base 3 of 3x plus 5 is equal to 12. Now notice, because of this subtraction symbol right there in the middle, we can actually rewrite this where it's the log base 3 of our initial expression, 9x squared minus 25, divided by our second expression, 3x plus 5. Of course, this will be equal to 12. Now from here, remember, this is clearly going to be a difference of squares. Why? Because you can take the square root of 9 and that's equal to 3, and you can take the square root of 25 and that's going to be equal to 5. And so what can we say here? We can say this is actually equal to the log base 3 of, everything's still going to be over 3x plus 5, but of, and when we split this up we can say, okay, well that 9, the square of 9x squared is 3x, plus the square root of 25 is 5, times 3x minus 5, because remember it's the difference of squares, and all of this is of course equal to 12. Now here, because there's a 3x plus 5 on the bottom and it's 3x plus 5 on the top, those cancel, and we have the log of base 3 of 3x minus 5 is equal to 12. Now of course from here, how do we get rid of the log base 3? We put everything into the exponent of 3, those cancel, and we're going to have a pretty wild number over here. We could say this, we could say 3x minus 5 is equal to 3 to the power of 12. That is going to be a large number. 3 to the power of 12 is 531,441. I think I wrote that down right. Was it 531? Yeah, perfect. Now from here, guys, we're just going to do simple math. We're going to add 5 to both sides. Hey, adding 5 to that's not too bad because we have 3x is equal to 446. And then we can just take that and divide it by 3. Well, here, let's do it here first. Divide by 3, divide by 3. And so let's just go ahead and do the addition right here. We can say, okay, answer plus 5. Sorry, I couldn't find that for a second. And then, of course, we'll take our answer, and we will now divide it by 3. And we'll see that our final answer is 177,148. And, oh, I'm sorry, guys. Kind of all over the place right now. Let me find the space to erase for our answer. Say x is equal to 177,148.67. All right, let's move on to a third example. Okay, now if you're struggling with these factorings, notice, guys, I'm always going to put something here that is a factor of the original. So that should be something that can help you out. So say, okay, we now have the log base 8 of x squared plus 8x plus 16, all divided by x plus 4. And this is equal to 2. And we want to ask ourselves, well, what can we factor? What can we factor this top thing into? Notice it's no longer a difference of squares. So in this one, we want to say, okay, well, what times what gives me x squared? We know that that's going to be x times x. Okay? And what two numbers add up to be 4 and multiply to be 16? We're going to write x plus 4, and all of this is going to be over x plus 4 is equal to 2. Now from here, we can factor out what we have that's on the common on the top and the bottom, and we have a log base 8 of x plus 4 is equal to 2. And now, guys, we're back to a very simple problem. Since it's a log base 8, we'll raise everything up into the power of 8, and that cancels. We can say, okay, you know what we really have? Let's bring this up here. X plus 4 is equal to 8 squared, which y'all all know is 64. And then once I subtract 4 from both sides, I get x is equal to 60. All right, let's move on to our fourth and final example. All right, y'all, here's our fourth and final example. We have the log base 9 of x squared plus 7x plus 12 minus the log base 9 of x plus 3 is equal to 3. So let's go ahead and rewrite this. Using our quotient rule, we'll take what's in the first logarithm, x squared plus 7x plus 12. We'll divide it by x plus 3, because remember we divide when the logarithms are being subtracted. And we'll set that equal to 3. Now if you will recall, to get rid of this, my apologies, first let's go ahead and factor what we see on the top. I know that this can be written as x plus 3 times x plus 4, because remember 3 plus 4 is 7 and 3 times 4 is 12, all over x plus 3 is equal to 3. Now because there's x plus 3 on the top and bottom, they cancel, and we have the log base 9 of x plus 4 is equal to 3. From here, since our base is 9, we'll raise everything into the power of 9, and those cancel, and we now have this, x plus 4 is equal to, and guys, 9 times 3, I think that's 781, but let's find out. Or, no, I'm sorry, 9 to the power of 3. Oh, it's 729. Okay, and we'll say that this is equal to 729. And from here, guys, we'll finish this off by subtracting both sides by 4. And x is equal to 725. Alright, y'all, I hope this has been helpful, and I'll catch y'all in our next lesson.